Okay, so today we are looking at factoring using the greatest common factor, and our learning target today is that we will be able to find the greatest common factor and then factor a quadratic expression or quadratic equation using the greatest common factor. So we will do a brief review of the distributive property because factoring is very much like the inverse operation of the distributive property. So when we work in math, every operation has an inverse operation. The inverse of addition is subtraction. The inverse of multiplication is division. The inverse of squaring a number is taking the square root of a number. The inverse of cubing a number is taking the cube root of a number. And the inverse of distributing is factoring. So we want to just practice a little review of the distributive property so that we have that fresh in our minds when we learn how to factor out a common factor. So remember that the terms in the distributive property, the terms outside the parentheses should be multiplied by all terms inside the parentheses. So, and just make note, x times x equals x squared. So example 1, 2 times x is 2x, and 2 times -3 is -6. So when we distribute the 2, we get 2x minus 6. Okay, example 2. X is going to be distributed over the quantity 4x plus 5. So x times 4x is 4x squared, and x times 5 is 5x, so plus 5x. Example 3, we're distributing a negative 4x, and it's really important to make sure that you distribute the negative with the 4x. So I recommend always circling, which I did not do in the first example. I recommend always circling the value that you are distributing so that you make sure you distribute the same thing to each term that's inside of the parentheses. So we're distributing a negative 4x. So negative 4x times 3x is negative 12x squared. Negative 4x times -7 is positive 28x. Okay, so remember an x times an x is an x squared, okay? Now, when we are working with the greatest common factor of a set of numbers is the largest factor that exists in all of the numbers. So all of the terms have to have that number and or variable in common. So for example, the greatest common factor of 8 and 12. Okay, so when we're looking at the greatest common factor of 8 and 12, we look at the factors of 8. 1 times 8 is 8. 2 times 4 is 8. So if you remember doing factor rainbows in 6th grade in elementary school, factors of 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. So when we look at all of the factors of 8 and all of the factors of 12, the greatest factor they both have in common is 4. So the greatest common factor of 8 and 12 is 4. Okay, so what about the greatest, this is just a refresher of greatest common factor that you learned in 6th grade. What is the greatest common factor of 6 and 24? So first, let's look at 6, and then we'll look at 24. So the factors of 6, well, 1 times 6 is 6, 2 times 3 is 6, and there are no numbers in between 2 and 3. Okay, so we're finished. We found all of the factors. 24, 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. And 4 times 6 is 24. And then 5, which is in the middle of 4 and 6, it's not a factor of 24. So we know we have found all of the factors of 24. So when we look at them, the greatest common factor of 6 and 24 is 6. All right, example 2. What is the greatest common factor of 12 and 8? So 12 and 8. Okay, 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Okay, the factors of 8, 1 times 8, 2 times 4, and then 3 is not a factor. So we are finished and we found all of the factors of 8. So then we look to see what's the greatest common factor. They don't have an 8 in common. They do have a 4 in common. So the GCF is 4. So that's just a little refresher of finding the greatest common factor of numbers. Okay, so then we can find the greatest common factor with variables, and then in today's work, we'll actually be doing both at the same time, but this is just the numbers part. Now let's look at the variables. So x is just x. X squared, so x has factors of just x. When we look at x squared, we can break that down into x times x. So what's the greatest factor they both have in common? Well, they have one x in common. So the GCF is just x. All right, let's look at example. Actually, example 2 is the same thing, just in a different order. So let's make this one x to the third. And let's just make that one x to the second, okay? So let's just change that a little bit just so it's not an identical problem. So x cubed, the factors are x times x times x, and then x squared. The factors are x times x. So what do they have in common? Well, they have an x in common and then another x in common. So here, the greatest common factor, x times x, is x squared. All right, so then let's put those two skill sets together, and the greatest common factor with numbers. All right, so let's put those two skills together, greatest common factor with numbers and with variables. So to find the greatest common factor when given numbers and variables, find the greatest common factor of the numbers, then find the greatest common factor of the variables. So when we look at 4x squared and 6x, so first of all, we know the variables or the factors of 4 are 1 times 4 and 2 times itself. The factors of 6 are 1 times 6 and 2 times 3. If you can do these in your head, you do not need to list these out. So I'm just showing every step so you know exactly where I'm getting all of the numbers from. So we can see that the numerical portion of the greatest common factor is 2. And then when we look at x squared and x, well, this has x multiplied by itself, so x squared, and the 6x just has x. So the only one they have in common is the x. So the greatest common factor is 2x. Example 2, okay, 7 and 3, they don't have any common factors numerically, so they just have 1 in common. So, and then if we look at x squared and x, all they have in common is x. So again, 7 and 3, they don't have any common factors. So when two numbers don't have any common factors, we call them relatively prime. They don't share any common factors, okay? And then x squared and x, all they have in common is x. Example 3, okay, 8 and 12. And if you can't do this in your head, you can go ahead and list all of the factors, no problem. So the greatest common factor, though, of 8 and 12 is 4. And we actually know that from our example up here anyway. But most of you probably can do that in your head. And then when we look at x and x squared, the greatest common factor is x. So 4x is our greatest common factor. All right, and let's go on to page 2 of the notes. Okay, so factoring examples, think of doing the inverse of the distributive property, find the GCF of the coefficients and the variables and write it down outside of parentheses. And then after you divide that out, write what is left over inside of the parentheses. So check your answers by distributing to see if you get your original equation back. So this is your check step. Okay, kind of like when you learn how to subtract, we had you add as your check step. Well, we're learning how to factor, so when you do your check step, you're distributing. Okay, so here we have the y equals, and we're going to leave the y, and we're going to look at our right-hand side of our right-hand side of our equation, and that's what we're factoring. Okay, so when we look at 4x squared and 2x, we know the GCF of 4 and 2 is 2. And then when we look at x squared and x, the GCF is x. So the GCF is 2x. All right, you don't need to write this down, but I am. I'm going to write that down. GCF is 2x. So this is what we are factoring out. We're factoring out the 2x. Okay, so when I say factoring out, what I mean is, So here's my multiplication. The parentheses mean multiplication. Okay, but since I'm multiplying it here, I have to divide it out of both of those terms and see what's left. Well, what's 4x squared divided by 2x? Well, 4 divided by 2 is 2, and x squared divided by x is x. 2x divided by 2x is 1, so plus 1. So our answer is y equals 2x times the quantity x plus 1. So let's talk about dividing with exponents. So when I have x squared, I had 4x squared and I factored out, or I divided out, a 2x. So really what I had was 4x squared, and I divided it by 2x because I factored out a 2x. So I'm dividing by 2x. Okay, well, what's 4 divided by 2? 2. What's x squared divided by x? And that's x. So let's break that down even more to the smallest level, and let's look at, 4 divided by 2 is 2, no problem. But how does this work, that x squared divided by x is equal to x? Well, it looks like this. If you just look at the variable component of this division problem, okay, so x squared divided by x, well, what does x squared mean? It means x times x. And then I divide by x. So what's x divided by x? It's 1. X divided by x is 1, just like any number divided by itself is 1. 2 divided by 2 would be 1 if these were 4s, if x equaled 4. 4 divided by 4 would be 1. Okay, if x were 10, 10 divided by 10 would be 1. If x were negative 10, negative 10 divided by negative 10 would still be positive 1. So it doesn't matter what the x is, any number divided by itself is 1. So x divided by x is 1. Okay, so now my answer is, I just have this x left over. So that's how I got the 2x when I divided the 4x squared and I factored out the 2x, I had 2x left over. And then I can check that by using the distributive property. So we'll just check the right-hand side to make sure we factored correctly. Obviously the y is staying the same. So 2x times the quantity 2x plus 1. If I distribute this, because that's how I can do my check step, 2x times 2x is 4x squared, and 2x times 1 is 2x. So 4x squared plus 2x. 4x squared plus 2x. So that checks out. So that was just a check step. You do not need to write out the check step, but I do expect that you're doing that mentally. If you want to write out the check step, you can. There's not a ton of room, but you can squeeze it in there. Let's look at example 2. 5x, so f of x equals 5x squared plus 20x. So what's the GCF of 5 and 20? It's 5. What's the GCF of x squared and x? It's x. So now I'm factoring out or dividing out a 5x. 5x squared divided by 5x is 1. 20x divided by 5x, excuse me, it's 1x. So we'll just write x. Let me say that one more time, I'm sorry. 5x squared divided by 5x is x. And then 20x divided by 5x is 4. So x plus 4. So in factored form, f of x equals 5x times the quantity x plus 4. Okay, example 3, y equals, okay, now we want our, to factor out, we look at the negative 2x squared plus 2x. We want our leading coefficient to be positive, so we're going to go ahead and factor out a 2x. Okay, that's the greatest common factor. So negative 2x squared divided by positive 2x is negative x, and then 2x divided by 2x is just 1. Okay, so y equals 2x times the quantity negative x plus 1. You could factor out the negative, and we will actually have, when we look at some types of factoring, we will actually prefer that. So you could also have this answer, y equals, I prefer this to have that leading coefficient to be positive. Okay, so let's make that known, that's a preference. But you could factor out a negative 2x as well. Okay, negative 2x squared divided by negative 2x is going to give you a positive x, okay, because a negative divided by a negative is a positive. And then positive 2x divided by negative 2x is negative 1. And then you would check that with your check step, okay? And I'm going to leave this boxed because that's the preferred answer. Number 4, f of x equals x squared minus x. So we can see that the only thing they have in common is the x. So we'll go ahead and factor out the x. F of x equals, okay, we're factoring out the x. So x squared divided by x is x. And x divided by x is 1. So f of x equals x minus 1. Okay, the GCF was just x. Number 5, y equals, okay, and we'll factor out, we look at negative x squared and 4x. The GCF is x, so we'll factor out the x. Negative x squared divided by x is negative x, and 4x divided by x is 4, so plus 4. Okay, if you factored out the negative, okay, y would equal negative x times the quantity, negative x squared divided by negative x is positive x, and then plus 4x, so positive 4x divided by negative x would be negative 4 or minus 4. Okay, number 6, y equals negative 6x squared plus 4x. Okay, so the GCF of negative 6 and 4 is 2, and the GCF of x squared and x is x, so we'll factor out a 2x. Okay, negative 6x squared divided by positive 2x is going to give us negative 3x, and then 4x divided by 2x just gives us 2. So y equals 2x times the quantity, negative 3x plus 2, and if you factored out the negative, so again, you could have a negative 2x here. Negative 6x squared divided by negative 2x is going to give you positive 3x. And then 4x divided by negative 2x will give you negative 2. Okay, and you can check those with your check step by distributing. Okay, number 7. F of x equals, okay, now when they're both negative, we do want to factor out the negative. All right, so let's factor out negative 2x. So negative 8 divided by negative 2 is positive 4. X squared divided by x is x, so that's 4x. And then negative 6x divided by negative 2x, and negative divided by negative is a positive. 6x divided by 2x is 3. Okay. If you factored out a positive 2x, okay, negative 8x squared divided by positive 2x, well, a negative 8 divided by positive 2 is a negative 4. X squared divided by x is x, so negative 4x. And then negative 6x divided by 2x would be minus 3, okay? And you'll notice this is the opposite, that's negative, that's positive, and these will be opposites, 4x, negative 4x, plus 3, minus 3. Okay, so if I give this answer and you have this one, you can look and see, are these opposites? Is 2x the opposite of negative 2x? Yes. Is 4x the opposite of negative 4x? Yes. Is plus 3 the opposite of minus 3? Yes. Number 8, y equals. So we look at 12 and 9. What's the GCF of 12 and 9? 3. What's the GCF of x squared and x? X. Okay, and then, so 12x squared divided by 3x is 4x, and negative 9x divided by 3x is minus 3. So we have 3x times the quantity, 4x minus 3. You wouldn't factor out a negative, but if you did, it wouldn't be incorrect, but typically we have that positive, that first term is positive, so we keep them both positive. Okay, then we look at number 9, f of x. 7 and 5 don't have any common factors, so the GCF is 1 there. X squared and x just have an x in common, so we're just factoring out or just dividing out an x. So 7x squared divided by x is 7x. And plus 5x divided by x is 5. So 7x plus 5. All right, so that is how we can factor out a greatest common factor from quadratics.